Everybody wants their computer to be fast, and as a result of that, when you're looking at CPUs, everybody thinks that faster is better. So let's talk about speed for a minute. First of all, when we're working with CPUs, CPUs do come with a rated speed. So for example, this particular CPU I have in front of me runs at, this is an old Pentium 4, there's a reason we're talking about this, and it actually has printed right on here 1.6 gigahertz. Now, a hertz is a time per second, and giga is a billion. So this can run at 1.6 billion cranks per second in essence. Now the question is what's cranking this system? If you see 1.6 printed right on the CPU, it would make you think that there's like a motor in here or something that's driving this and running it at 1.6 gigahertz per second. But that's not true. What's actually pushing this guy is the system crystal. Ever seen a system crystal? I got one right here. Now if you take a look at this motherboard, you can see right here, this little silver oval-shaped can right there, that's the system crystal. The system crystal really is just a piece of quartz that's oscillating at a certain speed. I believe that particular one right there is running at like 20 megahertz. So then there's internal circuitry that pushes it forward. So the important thing you need to appreciate is that even though this CPU says 1.6 gigahertz per second, that's its maximum speed. I could push this at 1 hertz, 1 cycle per second, and it would still run fine. It would still run really slow, but it would still work. So it's important to appreciate that this number that you see here is simply because it passed a certain number of tests. When you buy CPUs, you'll see the exact same make and model of CPU that comes out in 2, 3, 4 different speeds, and the faster ones are more expensive. So you'd say to yourself, wow, I bet they're coming off of 4 different manufacturing lines. Nope. Really what's happening is these all come off the exact same manufacturing line, but the ones that pass the higher speeds pass more tests. That's all there is to it. So it's really nothing built into the CPU that makes that speed. It's a matter of how many tests that it passed in order to achieve that. Now, what I want to do is, let's take a look at this motherboard one more time. We've got a system crystal down here, but it's running at a very low speed compared to what the CPU itself does. Now granted, there's some onboard circuitry that's going to take that 20 megahertz crystal and push it up to, depends on the motherboard, usually around to 200, maybe as low as 100, up to 200 megahertz. Now the question is if the motherboard's only running at 200 megahertz, what's making the CPU run at 1.6 gigahertz? Well, what's happening in here is you have something called a multiplier. The CPU itself can run a lot faster than your motherboard can. Motherboards, just because of the very nature of their design, really aren't designed to run much faster than about 200 megahertz. So CPUs will take that motherboard speed and then they'll increase it, usually by a factor of anywhere from as low as maybe 8 up to about 16 or even 20. And it takes that, multiplies it, and that's where you get that speed from. So if I've got a 1.6 gigahertz CPU and I put it on a 200 megahertz motherboard, that means, let me do the math in my head, I have an 8 times multiplier. 200 times 8 is 1.6, you got it. And that's what clock multipliers are. This is all handled automatically. You'd have to go back in the old days, and it used to be you'd have to move jumpers and stuff. But today, as long as you've got the right CPU for your motherboard, you just drop it in and you can adjust this stuff. Now, what's a little interesting, I just want to throw this in as a side, is that you can buy motherboards that are known as overclocker boards. And what I can do is I can push this CPU faster than its rated speed. So if this is 1.6, I've got a 200 megahertz motherboard. Instead of making it times 8, what if I made it times 10? Now keep in mind, it's going to be running faster than its rated speed, correct? Nothing wrong with that, other than the fact that Intel would be very crabby because they put it through a number of tests to make it run at 1.6, and now you want to make it run at 2 gigahertz. So that's called overclocking, and we'll cover that in more detail in other episodes. But for right now, I want you to appreciate that overclocking simply means to push the CPU beyond its rated speed. The Pentium 4 was a very interesting CPU. When it came out about 10 years ago, a little more than that. The Pentium 4's microarchitecture was designed to have it run at what eventually would be very, very high speeds. Around 10 years ago, we thought we'd be getting up in the area of 6 gigahertz, 7, 8 gigahertz by now, and that the Pentium 4's microarchitecture would carry it along over all those years. Well, it didn't quite work out that way. It ends up that when you start trying to run at really, really high clock rates, we don't really have the technology to do that very, very well. I mean, we do, but it's expensive. So what we've started to do instead is we'll take a single CPU and in essence put, I don't know, 2, 4, sometimes 8 CPUs within one physical chip. If we can't get much faster, right now getting much beyond, say, 3.5 gigahertz is pretty hard. So if we want to get past that, we can't get faster clocks, so we'll just give you more CPUs. So while this may look like a single CPU, in reality it's either 2 or 4, 8, it depends on what microarchitecture you're using to define what are known as cores. Now, if you want to see some cores in action, let's take a look at CPU-Z one more time. All right, so here I am taking a look once again with CPU-Z, and I want you to notice down here at the bottom, well, first of all, you notice that this tool, it says processor number 1, but it's grayed out. If I had a motherboard that could accept 2 or 4 processors, I could literally choose a particular one. But that's not what we're talking about. When we're talking about processors here, we're talking about physical chips. But built into this one Core i7 are 4 cores. You see it right there. Now, if you have an Intel product, and in particular it has to be a Core i7, you get another very, very cool feature which will take one core and make it look like 2 cores, and that's called hyperthreading. Now, for me to show you that, I need to bring up Task Manager. And you'll see I've got Task Manager already preset to the Performance tab, and if you take a look right here, you can see it 1, 2, 3, 4, 5, 6, 7, 8. In essence, we have 8 cores. Now, I got to be honest with you, really physically, we only have 4 cores, but because we're running hyperthreading, because it's an Intel i7, we make it look like 8 cores. Clock speeds and cores are an important part of understanding your CPU. Number 1, always remember that the CPU itself is actually sold at a particular rated speed. But that speed is driven by the system crystal. The system crystal pushes out a particular speed, which we call the motherboard speed, which is then multiplied internally by the CPU to get that full speed. The number of cores that you have in your CPU really depends on how thick your wallet is more than anything else. It's not at all uncommon to have one particular microarchitecture that can support, let's say, 8 cores, but they'll turn off half the cores for lower priced items and turn off maybe down to as low as 2 for even lower cost CPUs. And as a result of that, then the number of cores you get really depends on how much money you're willing to spend. Also, keep in mind that hyperthreading literally takes 1 core and makes it look like, at least to Windows, 2 cores. So as a result of that, if you see a system, you're running CPU-Z or something like that, you know you have 4 cores, but then you're in Task Manager and all of a sudden you see you've got 8 CPU meters, you know instantly that you're running hyperthreading. And remember about hyperthreading, it's only for Intel, and CompTIA loves to ask that question.